Good morning, guys. Today we're going to talk about something called the rational zero theorem. So, just a little bit of vocabulary. Remember that zero means a solution or a root. So, solution, root. They both mean the same thing as zero. In fact, probably the easiest way to think of a zero is the x-intercept. So, when you graph it, where is it crossing the x-axis? Rational, so this first word just means that you could write it as a fraction if you wanted to. So things like, fractions obviously, 2 over 3, 5 over 6, but also things like 0.25. Right now it's a decimal, but you could write it as 1 over 4. Whole numbers, so something like 10, you could write it as 10 over 1. So as long as it could be written as a fraction, it is rational. So the rational zero theorem, so it means that if a polynomial has integer coefficients, so integer means whole numbers, then every rational zero of the function has the form. So the zeros are always going to be x equals. And then they say p over q, but this stands for something. P stands for all the factors of the constant. So remember, constant is the one that doesn't have a variable next to it. It's just a regular number. And then Q stands for all factors of the leading coefficient. So that would be the very first coefficient that you see when it is written in standard form. So when you look for the biggest exponent, whatever number is in front of that letter, that's the leading coefficient. So the reason why we use this is because sometimes we'll have polynomials that we don't know how to factor. But that doesn't mean that it doesn't have actual factors. It just means that we are having trouble getting started. So like, for example, let's look at that very first one. It says to list all possible rational zeros of each function. So we're not going to, at first, we're not going to do all possible. It's just try to find any zeros of that. So I have x to the third, x to the second, x, whatever. So it's already in standard form. So I would try to factor it, but this last one doesn't have an x, so I can't factor out the x. So the next thing I would try is factor by grouping. So I would split it down the middle. But here, the only thing I can take out is the x squared, which would leave me with 2x plus 11. And then on the other side, I can take out 4, I think. So plus 4, but then that would leave me with 7x plus 6. What's in the parentheses is not the same, so factor by grouping didn't work in this case. So what do we do then if we don't know how to factor this? So that's where the rational zeros comes in. Okay, so instead of trying to factor it, we're going to find all the possible numbers that could be zeros. So all possible. So think about it this way. Any number in the whole world is a possible answer. So negative infinity all the way to positive infinity. So we're going to narrow down that list. Okay, so x equals all the factors of 24. So that's what we call P, divided by factors of 2, because that's the leading coefficient, that would be Q. So factors of 24. Let's just go down the list. I know I could do 1 times 24, but it could be positive or negative. So plus or minus 1, plus or minus 24. Okay, it's an even number, so I know I could do 2. So plus or minus 2, plus or minus 12. 3 will also work, so plus or minus 3, plus or minus 8, plus or minus 4, plus or minus 6, so 4 times 6. And I think that's it. So those are all the factors of 24. These right here. So that would be all the numbers that would go in the numerator. Denominator is factors of 2. So the good thing about 2 is that it's prime. So the only factors it has is 1 and itself. Okay, but now let's find all the possible zeros. So it's going to be a bunch of fractions and a bunch of dividing. So x equals well, all of these over 1 are going to stay the same. 1 over 1, 24 over 1, 2 over 1, 12 over 1, 3 over 1. So since they're all going to stay the same, I'm going to go ahead and just rewrite them all. Okay, so we're done with this 1. But now we need to put them all over 2. So 1 over 2 would be 1/2. So plus or minus 1/2. 24 over 2, well, 24 divided by 2 is 12, and that's already on our list, so we don't need to write it again. 2 over 2 is 1, and that's already on the list. 12 over 2 is 6, and that's already on the list. 3 over 2, okay, I think that one's new, so we're going to need to write that one. Plus or minus 3 over 2. 8 over 2 is 4, and that's already here. 4 over 2 is 2, and it's already here. And then 6 over 2 is 3, and that's already on the list. So these are all the possible zeros that we could have. So I know it's still a long list, but think about it. Instead of having negative infinity all the way up to positive infinity, so infinite numbers that we could guess, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We narrowed it down to 10 options. So from those 10, you can start dividing and see which one works. But it's a lot better than having to do infinite guesses. This way, you only have to guess 10 times. Okay, so let's do the next one. This one is 3x cubed minus x squared minus 18x plus 16. So same thing. I would try to factor it. So I'm going to do my factor by grouping, factor out an x squared. So that's 3 minus 1. And then over here, I would factor out a 2. So this would be 9x plus 8. It does not factor. But that doesn't mean that it's not going to have zeros. So we're going to list all the possibles. We could do all the factors of 16, because remember that's P, divided by all the factors of 3, because that's Q. So let's start with 16. So everything is always plus or minus, because it could be positive and it could be negative. So plus or minus 1 times plus or minus 16. That's the most obvious one. It's an even number, so I know I could do 2. So plus or minus 2 times plus or minus 8. 2 times 8. What else? And then we could do 4 times 4. You don't need to write it twice. You could just write it the one time. So plus or minus 4. Those are the factors of 16. Okay, now the factors of 3. Again, this is pretty simple because it is a prime number. The only factors that it has is 1 and itself. Okay, so now we need to go through and find all the possible fractions that we can make where all of these numbers are the numerator and these numbers are the denominators. Okay, so x would equal Well, the 1 in this case means that all of them are going to stay the same for the top. So I'm going to go ahead and rewrite those. 1, 16, 2, 8, and 4. So we're done with this 1. But now we need to try all of these divided by 3. So 1 over 3 is 1/3. That wasn't on our list yet, so plus or minus 1/3. Then 16 over 3, not on our list yet, so we need that one as well. 16 over 3, can we simplify? No, so it's going to stay 16 over 3. Next one is 2 over 3, plus or minus 2/3. Next one is 8 over 3, plus or minus 8/3. And then last would be plus or minus 4/3. So in this case, nothing repeated. They all individually have to be on the list. So that's us narrowing down what we would guess. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, down to 10. Instead of having to guess from infinite numbers that are out there, these are the only 10 numbers that it possibly could be. Not all of them are going to work, but our zeros are somewhere in that list. Okay, and then one more example. F of x equals 6x to the 5 minus 8x cubed plus 9x squared minus 12. Same, if you try to factor it, it's really not going to work. So we have to use the rational zero theorem. So we need all the factors of 12 divided by all the factors of 6. So these are smaller numbers, so hopefully it's not too bad. Factors of 12, plus or minus 1 times plus or minus 12. Plus or minus 2 times plus or minus 6. And then you could do 3 times 4. So plus or minus 3, plus or minus 4. Okay, and then for 6, this time, our denominator, it's not a prime number. 6 has more than one way to multiply and get it. You could do 1 times 6, or you could do 2 times 3. So I thought this one was going to be shorter, but in fact, I think it might be longer than the other two. So we need to come up with all the possible combinations of fractions where these numbers are the numerator and these numbers are the denominator. So x equals 1 as a denominator just means that all these numbers are going to stay the same. So plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. So we're done with the 1. Now we need to try dividing by 6. So I'll have 1 over 6. That's new, so we have to write that. Then I have 12 over 6, but 12 divided by 6 is 2, and 2 is already on the list, so we don't need to worry about that one. 2 over 6. 2 over 6 simplifies to 1/3, so we need that one, plus or minus 1/3. 6 over 6, but that's 1 and it's already on the list. 3 over 6, that's 1/2, so we'll write that. And then 4 over 6 simplifies to 2/3, so we need this one. Okay, so now we're officially done with that 6. Now we need to go through and use 2 as a denominator. So 1 over 2 is already here. 12 over 2 is 6, which is already on the list. 2 over 2 is 1, already on the list. 6 over 2 is 3, already on the list. 3 over 2, that's not on here, so we need to write that. I'm going to write it at the bottom because I'm running out of space. So plus or minus 3/2. And then 4 over 2 would be 2, and that's already here. Okay, so we're done with the 2. Lastly, we need to do the 3. So 1 over 3, already on our list. 12 over 3, that would be 4, and it's already on our list. 2 over 3 already here. 6 over 3 is 2 already here. 3 over 3 is 1, it's already here. And then 4 over 3 is 4/3, and we don't have that, so we need to write it. The plus or minus 4/3. Yeah, so this one was a little bit longer. That's probably why I made it smaller numbers. But just like before, instead of having to guess from infinite amount of numbers, now you would just have to guess from something on this list. So the solutions to that polynomial are somewhere in the list that we just made. Okay, so that's the rational zero theorem or the rational root theorem. I think on your paper, on your assignment, I called it the rational root theorem. It's the same thing. So all I did was give y'all 2 problems to try on your own and just list out all the possible zeros that could be from that function and let me know if you have any questions.